So the average speed of a runner in a 400-meter race. So the distance is 400 meters. The distance involved 100 meters. And we are told that the average speed is 8.0 meters per second. Here I saw a lot of you using 5, but I marked it based on how it is supposed to be calculated, used. So whether you use 8 or 5, I still marked it. Okay. So the average speed 8.0 meter per second. The question is that how long did it take the runner to complete the race? So average speed V, the average speed is also the effective speed. So speed velocity is given by the total distance traveled over time. So here it's expected to make time the subject, which is total speed divided by the average speed. Total distance 400 divided by average speed 8. So the results is 50 seconds. Those of you who used 5 seconds also had 5 seconds also had 80, and I considered that. Then question 2. Which graph best represents the relationship between velocity and time for an object that accelerates uniformly for 2 seconds, then moves at a constant velocity for 1 second, and finally decelerates for 3 seconds. And note that we were not told that the body decelerates to rest. If we were given such information, then the graph would intersect the time axis or end at the time axis. So per the information given to us, the obvious graph is the first one, A. So question 2, A graph is a correct graph for the information given. Question 3. Question 3. The graph below represents the motion of an object traveling in a straight line as a function of time. Please mute yourself. 3. What is the average speed of the object during the first 4 seconds? Okay, so when you look at the graph carefully, from 1 to 2, from 0, 1, the time 0 to 2, the distance covered increased gradually to 3 meters. Okay, from time 0 through to 2, the distance covered increased gradually, okay, to 3 meters. So increase to 3 meters from 0 to 2. Then from 2, the maximum distance covered was 3 meters at 2 seconds. Then at 3, the body's position was the same, stationary. 4, stationary. So within the time interval 0 to 4 seconds, the total distance traveled is 3 meters. Within the interval from 0 to 4 seconds, The total distance traveled was 3 because the maximum distance traveled occurred at 2 seconds, and from 3 to 4, the body was stationary. Okay, so the average speed would be equal to, which is total distance by total time taken. Total distance traveled 3, total time taken is 4. So it must be 0.75 meter per second. Please note that this is a velocity time graph. Displacement time graph. Any question here? So when a question is given, note the kind of graph involved. Is it distance time graph or displacement, velocity time graph or displacement time graph, and use it appropriately. Question 4, that is using the graph. I'm coming. Please, if you have any question, ask whilst I review the question. I'm looking at the graph code. Okay, I'm there. Please mute yourself for me. Oh. So base your answers to questions 4 through to 9 on the graph above, which represents the relationship between speed and time for an object in motion along a straight line. Now, question 4. Question 4. Please let me mute all so that if there is a need for you to contribute, you come in. Others have not muted. All right, so question 4. What is the acceleration of the object during the time interval 3 seconds to 4 seconds? So what is the acceleration of the object during the time interval t is equal to 3 seconds to t is equal to 5 seconds? Okay, and this is question 4. For a velocity time graph, last time we saw that the slope of a velocity time graph or speed time graph would give you the acceleration. The slope of a velocity time graph is equal to the acceleration of the body. So once we are asked to find the acceleration within the time interval t is equal to 3 to 5, it means we must look at the slope to the time. Okay, and the slope is changing the vertical. The slope is equal to change in the vertical delta v over change in the horizontal delta t. Now, within the said time interval, okay, the maximum distance traveled 25, maximum speed 25 minus the minimum time which correspond to minimum distance, velocity or speed which corresponds to the time 3 seconds is 10. So minus 10 divided by change in time, and the change in time is 5 minus 3, which is 2. So we have 15 divided by 2, which is giving us 7.5 meter per second squared. So this is the slope or the acceleration traveled within the time interval 3 to 5 seconds. Any question? If you have any question to ask, you can. Emelda.
Sir, please, why do you use 25 and 10?
Okay, so Emelda, look at the time, the third time interval. We are to find the acceleration between the time interval t is equal to 3 seconds and t is equal to 5. So look at the interval from the graph. Okay, trace the time t is equal to 3 to the time, and it will be on 10 seconds. Then trace the time t is equal to 5, okay, to the graph, and it will also be on 25 seconds. So the slope is changing vertical divided by changing horizontal. And so if I want to find the difference in the velocity corresponding to the time, it will be 25 minus 10, all divided by a time interval from 3 to 5 seconds, which is 2 seconds. Imelda, this is the reason why I took 25 and then 10. Are you okay?
Yes, please.
So you must trace it to the time given in the question. All right, question 5. What is the average speed of the object during the time interval t is equal to 6 seconds to t is equal to 8 seconds? The first consideration is that how do we calculate average speed? V average, which is the effective speed, is equal to total distance traveled divided by the total time taken. What is the total distance traveled? You see, for a velocity time graph, the area under the graph would give you the total distance covered. So it means that the area under the time interval from 6 to 8 would give us the total distance traveled. So if we want S, the total distance traveled, then we must consider the area between the third time interval and the shape formed under the graph within the time interval is a trapezium. So I can determine the area using the area for determining, or area of a trapezium, half times A plus B times H. What is A? A is the smaller side of the two parallel sides. So from the graph, area A, the length A is equal to 10. Is equal to 10. So this is 10 plus the other parallel side, which is B, corresponds to the time 6. And this is equal to 25. Multiplied by height. The height is that perpendicular length, the side which is perpendicular to both A and B. And that is of the side length or height is 2. The interval between 8 and 6. So this is equal to 2. 2 and these 2 cancels out, and we have 35 meters as the total distance covered under the time interval. So 35 divided by a time interval of 2 would give us 17.5 meters per second. So that is the average velocity or speed under the third time interval. Any question?
No.
Sir, please, I did not understand anything.
Marilyn, you see, average distance, average velocity or speed is total distance over total time taken. So you must look out for the total distance during the time interval from 6 seconds to 8 seconds. Okay. Now this distance can be obtained using the formula for finding a trapezium, because the shape under the set time is a trapezium. The shape looks like this. Okay, corresponding to this is 6, this is 8. Now, this side, which is A, this is A, this is B. A has a length of, from the graph, A has a length of 10. So that is what I've used here. A is equal to 10. That's what I've indicated here. And this length B from the graph corresponds to 25. Marilyn, are you okay? Marilyn, are you there?
Yes, sir.
The height is always perpendicular to the size A and B. So this line is perpendicular to both A and both B, and that is H. H is the interval between the set time. So 8 minus 2, and that's what I've indicated here. Okay, so the area of the trapezium is equal to the distance, total distance traveled under the set time. And so these two would cancel, and we only sum up the numbers within the bracket, which is 35. So, Marilyn, it means that the total distance traveled is 35. The total time taken for this distance is 8 minus 6, which is 2. This is how come we got 17.5 meters per second. Marilyn, are you fine?
Yes, sir.
Thank you. Question 6. Interestingly, a lot of you got this wrong, and I was so disappointed instead of being appointed. The question says that what is the distance traveled by the object during the first 3 seconds? During the first 3 seconds. And looking at the graph, the first 3 seconds, 0 to 1, 1 to 2, and 2 to 3. What is the shape under the set time? Can somebody tell me the shape created with under the set time? What is this shape? Yeah, Giovanni.
A trapezium.
Trapezium. So either you use the area of a trapezium to determine this distance traveled, or you segregate it into triangle and then rectangle. Okay, I'm just sketching for 0 to 1. Then this is 3. And the speed involved is 5. 10. So area of a trapezium, this is A. From this point to this point is B. So half A is equal to 2. 3 minus 1, 2, plus B is 3, times the height, which is this. Perpendicular to both A and B is 10. Therefore, 2, 5. We have what is in the bracket to be 5 times another 5, equal to 25 meters. Area under a velocity time graph is equal to the total distance traveled. So once you determine the area under the set time is equal to the total distance, you can also solve the same problem by dividing this area into two, one triangle, another rectangle. Area of the triangle, half base times height. The base is equal to 1. The height is 10. This totals 5. Then the area of the rectangle, length times breadth. 10 times breadth, which is equal to 2. So 20. When you add the 2, it is still equal to 25 meters. So I was surprised to see a lot of you getting this wrong. Benjamin.
Yes, sir. Sir, please, can you go over the number 6 again?
Number 6, you see, area under a velocity or speed time graph is equal to the total distance traveled. So that's the first thing you must understand. Area under a velocity time graph or speed time graph is equal to the total distance traveled. So when you look at the set time is during the first 3 seconds. So 1, 2, and 3 seconds. These are the first 3 seconds. And the area there is the area of a trapezium. So either you use the area of a trapezium to calculate for the total distance, or you divide the area of a trapezium into 2, triangle and then a rectangle. Find the area of the triangle, find the area of the rectangle, and add. Okay, so both ways must give you the total distance traveled. So I earlier used the area of a trapezium had 25, and then later divided the area into a rectangle, sorry, a triangle and a rectangle. The triangle gave me 5, whereas the rectangle gave me a total distance of 20. When you add, the value is still the same as using that of a trapezium. Benjamin, are you fine?
Yes, sir.
Question 6. Question 6. Sorry, 7. During which interval is the object acceleration the greatest? Yes. This part 2 was a bit funny because a lot of you were analyzing using slope. Yes. If two graphs under a velocity time graph are at the same point, let me sketch. This is V T graph. And then the two graphs happen to come from the same point, like this. Another one like this. Ladies and gentlemen, if I have a graph of this nature, A and B, I can easily use visual judgment to determine the acceleration without calculation. This is because they are all coming from the same point. So clearly by this, it means that the one that is very steepy must give me, or steepy or slopey must give me a higher acceleration. Okay. So by this, I can easily say that, oh, the first motion or body A would have a greater acceleration compared to body B. And this is because they are coming from the same point. So I'm using the steepiness or how slopey the graph is But if they are not coming from the same point, you can't just look at it and then conclude that, oh, because you think, especially if the graph is like this. This graph or this motion A is like this, and another motion the motion went like this, and another one went like this. This is maybe B. Okay, B must be here, and then this is C. Okay, the body is accelerating at A. The body is also accelerating at C. At B, the acceleration is 0. So I have this, and my judgment is that C is slopey than A. And so the acceleration of C is greater than this. No, I cannot say this because they are not from the same point. If the motion like had been like this, and this is C, I can say this, but not this. If you have a situation of this nature, please calculate to determine. You must use calculation. Class, are you with me?
Okay.
So use calculation. So let's calculate. From the graph, it's obvious we have acceleration between 0 to 1 and 3 to 5. 3 to 5, we earlier calculated and had 7.5 meter per second squared. We can calculate again the slope of, okay, the line, straight line between the time interval 3 to 6. So 25 minus 10 divided by a time interval of 2. So 15 on 2, giving us 7.5. That is between the time interval 3 to 5. Then the slope during the time interval 0 to 1 second. Okay. The change in vertical is 10 minus 0 over 1. And this is 10 meter per second squared. So it is obvious the time interval from 0 to 1 has the greatest or the larger acceleration. And we are considering 0 to 1 and 3 to 5 because all the rest are all either 0 acceleration or deceleration. That is why we are only interested in these two. Class, is that understood? If you have any concerns, please give me 1 minute to take attendance and get back to the house, okay? Attendance very important to ensure that everybody gets involved. So 1 minute to go through that. Whilst I take attendance, please, if you have a personal question, quickly ask so that I would throw more light at it for you.
Recording in progress.
Anna, are you there?
Hmm? sir.
Okay. I wish I could mention all names. All right, so I think we can continue. Okay, so I think we are on question 8, right? During the interval t is equal to 8 to t is equal to 10, the speed of the object is, okay, so here I gave it out as a bonus because ideally I should have given you, it's such a, it's the kind of question with alt to pick from, okay, but I kept quiet and then was expecting how best you can think. And the good news is that a lot of you actually saw it. But you see, the correction I want to, the question is about the speed of the object s. When you look at the interval t is equal to 8 to 10, the object speed is decreasing. The object speed is decreasing. Some of you were saying that the object was decelerating. Yes, it's true the object is decelerating, but the emphasis is not on the object, it is on the speed. So the best way out is that the object speed is decreasing. All right. And when the object speed is decreasing, the object is decelerating. 9. What is the maximum speed reached by the object during the 10 seconds of travel? Okay, the time in question is from 0 to 10. So during the whole 10 seconds of travel, what is the object's maximum speed? It is clearly 25 meters per second. So the maximum possible time speed embarked, okay, by the object during the 10 seconds of its travel is 25 meters per second. Then the last question, 10. An object is displaced 12 meters to the right. So let's assume the object starts from a reference point like this. We are told that it is displaced 12 meters to the right. So this is the right, and the displacement of the object 12 meters. So the object is now here, and then 16 meters upward from its current location, it is displaced 16 meters upward. Let me clear some things, those stuffs I have, and then use the space. Then 16. Let's assume this is 16 meters. So this is the final location of the object. What is the magnitude of the resultant displacement? So this is the direction, is displacement. Then upward, this is the direction. The two directions are in place. And please, whenever you have motion along two directions, to the right or due east and then due north, okay, you must use you must realign their direction and use Pythagoras theorem to find the displacement. Okay, if the object move in one direction, an object move 12 meters to right and another 16 meters to the same direction. So this is 12, then continued from there 16. Then you just add to get the total displacement. But when the object is moving in two directions, x and y, you must use Pythagoras theorem. Okay, so the shortest possible distance equivalent to the two displacement is drawing from here to here. When we come into begin vectors, you understand better. So to get this, the motion forms a right angle triangle, and so you use Pythagoras theorem. C squared is equal to AB. A is 12, B is 16. So A squared plus B squared, which is 12 squared plus 16 squared. And the answer is 20 meters. A lot of you got this right. So this is motion in two dimensions. So that's it. Please, any question? Any question? Okay, so what I'll do is that I'll give you a half rank.
Sir, please, could you explain the number 8 again? The number 7, sorry.
Number 7.
Yes, please.
During which interval is the object acceleration the greatest? Okay, when you look at the graph, from 0 to 1, the object is uniformly accelerated. From 1 to 3, 0 acceleration, meaning velocity is constant. From 3 to 5, the object is uniformly accelerated again. 5 to 6, 0 acceleration. 6 to 8, a uniformly decelerated motion. 8 to 10, another uniformly decelerated motion. So once the question is about during which interval is the object acceleration the greatest, I stick to where I have uniform acceleration. And that is obviously between the interval 0 to 1 and 3 to 5. So calculate, since they are not at the same point, you can use how steepy or slopy is the motion or is the graph to judge the magnitude of the acceleration. So if they are all at the same point, like I've indicated here, then we can say that this one will be greater than this because this is slopy or steepy than B. They are at different points. So calculate the slope between for this, and this is from 0 to 1, and determine the slope for this time interval. This is 3 to 5. 3, 5. So the slope here, which is change in the speed, change in the time, then the slope for this one, which is also change in the speed over change in the time, would give you the acceleration. And when you compare, you realize that the time interval from 0 to 1, that is the slope, is greater than from 3 to 5. Frank, are you okay?
Yes, please.
So I'll give you another set of questions using graphs after today's lesson so as to deepen your understanding. Is that Ina? Your hand is up. I'm listening.
Sir, please, I'm not understanding how the 12 is the number 10. 12 is the power 2 plus 16 is the power 2, like I guess it's like 20.
I'll go through. Okay. I just jumped thinking you have all of you are following. So I'll go through. So we have c squared, which is the displacement of the 12 meter and then the 16. We don't know. C is what we don't know. And this will represent the shortest, okay, the resultant force is defined as that single force whose effect is equal to the combined effect of a number of forces. This is about displacement. So this represents what this and this one, when added, will do. So what this alone can do is equal to combining this one and this one. Okay. So c squared is 12 squared plus 16 squared. 12 squared is 144. Ina, what is 16 squared? 16 times 16. Class, what is 16 squared? Benjamin, go ahead.
256.
Come again.
256.
256. So when you sum the two, this must give us 400. So c squared is equal to 400. Finding c, you must take the square root of both sides of the equation. Or both sides. So when you take the square root of c squared, the power 2 vanishes. So you have c is equal to square root of 400, which is
20.
20. So this is how we got it. Okay.
Thank you, sir.
Welcome. Any more questions? Okay, so then let's move to equation of motion. We've done graphs of motion. So let's quickly look at, Priscilla, are you here? Priscilla is not here. So equation of motion. We have three main equations of motion. Okay, and as disciples of physics, you must understand how each one of them is derived, and also master how to use them in solving problems or questions. So this is about motion in a straight line, the kind of motion you and I, cars, and a lot of items exhibit in everyday life. Okay, Eldad, and then Janelle. Janelle, I'm sure, I don't know if you are okay now. Eldad, Janelle, I'm just reading the message. Are you there?
Yes, please.
Janelle, are you better? Are you okay?
Okay.
Which of the questions? Which of them?
Please, I only meant the one that I said that is average speed the same as acceleration.
Okay. Average speed is not the same as acceleration. Average speed, Janelle runs from the house to the school field. I don't know what Janelle is going to do, but your journey is from your house to the school field. If I want to calculate the average speed is also known as the effective speed during your whole journey. Okay, so this is your initial location, house. And then you cover some distance to the school field. So during your motion, what is the effective speed during the whole motion? And that is average speed. I can determine that by determining or knowing the total distance covered from your house to the school field. Okay, so total distance divided by the total time taken. Maybe when you were moving, there was a church. So the distance from here to here, and then the distance from here to here is the total distance. And a measure of this is what we are calling as the average speed or the effective speed. Now, when we talk about acceleration, we are looking at the change in speed or velocity with respect to time. So look at this. So this is total distance or displacement over total time. And when we talk about acceleration, it is a change in speed or velocity over time. Janelle, are they the same? Looking at the equations, are they the same?
Please.
Come again.
No, please.
So, okay. So what is acceleration in this case? You took off from house when you were just at rest. You were not moving. Then you increase your speed from rest. When your speed was 0, you increase your speed. Maybe you were increasing your speed till a final speed of this. So if I want to calculate how you accelerated, it is the change in your final speed and then your initial speed. The final speed is the speed you ended the journey with. Then the initial speed is, since you took off from rest, your initial speed was 0. So the time interval, okay, so this is acceleration. So practically when driving, you take off from home, then with lesser speed, because you can't run at top speed from your house. You start gradually. When you get to the road, because there are cars, you increase speed a little bit. When the road is okay, there are no much vehicles, then you can increase your speed. And so you press on the accelerator. So that is acceleration. All right. Please, is there any other concern to address before we move on to equation of motion? So average speed is not the same as acceleration. All right. Equations of motion. We can do these calculations as we've done without using graphs, but using mathematical equation. This is the very essence of equations of motion. Now, our equation of motion hinges on one condition, and that is the motion, it applies to only a uniformly accelerated motion. So considering a body in a uniformly accelerated motion, of initial velocity or speed u and a final velocity v, having covered a distance s within a time interval t. So our equations of motion hinges only on uniformly accelerated motion. So class, before we go through the nitty-gritties of the equation, I want to find out from you what uniformly accelerated motion means. Uniformly accelerated motion, what is it? Anybody to share the good news with me, since you are disciples of physics? Yes, what is uniformly accelerated motion? Frank.
Uniformly accelerated motion is when a body moves at a constant velocity.
Frank, sorry to disappoint you. No. When a body moves through a constant velocity, acceleration is zero. Benjamin. Benjamin, go ahead. I'm listening.
Yes, sir. Say, uniformly accelerated motion refers to the motion of an object where its velocity changes at a constant rate.
You haven't ended. The velocity changes at a constant rate.
Say, that was all I know.
No, somebody should add the remaining spices to garnish the stew. Frank.
Uniform accelerated motion is when an object is moving with a uniform acceleration. It's when a body change in velocity is equal to the interval of time.
Yeah, the idea is there, but putting the words together is the issue. Giovanni, your hand was up. Giovanni, go ahead.
Uniformly accelerated motion is when the velocity increases in equal interval within equal time interval.
So, yes, thank you. So, Benjamin, that's what you missed. Okay, your definition was fantastic, but you missed within equal time interval. So, in a uniform accelerated motion, we said that the rate the rate of change of velocity with respect to time is constant. Or in a uniformly accelerated motion, the body moves with equal velocity or speed within equal time interval. So these are two descriptions for a uniformly accelerated motion. Either the body moves with equal velocity or speed within equal time interval. And when you plot such a graph, I went through it with you. Velocity, time, you have a graph like this, and the slope along the line at every interval, the value is the same. Whether you pick a bigger slope or a smaller slope, you get the same value. And the value of the slope under this graph is equal to the what? Class, the value of the slope under this graph is equal to the... Hey, I'm listening.
Acceleration.
The acceleration. Good. And because this slope, which represents the acceleration, is the same everywhere, we say, the same or uniform everywhere, we say that the motion is a uniformly accelerated motion. So our equations of motion hinges on a uniformly accelerated motion, meaning that you cannot use this for a non-uniform motion. A non-uniform motion, it is always applied to a kind of motion whereby the speed or velocity increases, okay, in equal intervals within equal time or equal time. So considering a body in a uniformly accelerated motion of initial velocity u and a final velocity v, so it's like body starts from here and then ends here. Its initial velocity is u. It moves from this point to this point. And then the body ends with a final velocity v. Now during this change in velocity, the distance covered by the body is given as s. And it took a time interval of t to complete this side distance. Okay, so if we want to determine the acceleration of the body, class, how do we determine it? A body moving with an initial velocity, you find a velocity v within a time interval t, having covered a distance. How do we determine the acceleration of the body? Any idea? The girls, you are quiet today. Let's have one of the girls to also speak to us, okay? Any lady in the building, feel free to answer. The girls, Anita, you are here. Anna, you are here. Akosia, Ablina, okay, I was going to say Caleb. Okay. Oh, Benjamin, but you are not a girl. Benjamin,
Yes, sir.
you are not a girl. Yes. Anita, let me hear from you. How do we determine the acceleration of the body? Okay. Okay, Marilyn, go ahead.
Step is the final velocity minus the initial velocity over time.
Thank you. Thank you. So V minus U, and before, since we are developing concepts, so let's be systematic. Giovanni, your hand is still up. What is your secret? So,
It was a mistake.
okay. Since acceleration is changing velocity over time, okay, changing velocity is V minus U all over the time interval T. So A is equal to V minus U over T. Anna Gosling, help me make V the subject from what we have on the board. Help me make V the subject. Anna. Anna, are you there?
Yes.
Help me make V the subject from the equation. Anna, are you true?
Sir, please, D.
Mm-hmm. Yes, V is equal to. Okay. Mm-hmm.
Sir, please, D. V is equal to D.
Anna, we have A. This is A. Acceleration A.
A.
Mm-hmm. A.
A.
Uh-huh. Okay, so Anna is not true with it. Anna, look at it and I'll come back to you. Frank.
E is equal to U plus 80.
So U plus 80. How did Frank get his result? So
Sir,
in making V the subject, you first multiply through by T. T would cancel out. So we have AT or TA is equal to V minus U. And you must, because we are making V the subject, you must eliminate. Please mute yourselves, okay? Anna and Co, mute yourself. When there is a need for you to come in, then you unmute. To make V the subject, I must add U to both sides of the equation. This part goes to 0 because U minus U. So we have V is equal to U plus 80. Ladies and gentlemen, this is the first equation of motion.
Sir,
Hello, Frank.
please, for me, I cross multiplied both of them and I got V equals the U plus 80.
Come again.
So I cross multiplied both terms, then I got the U plus 80.
You have A is equal to V minus U over t. So when you cross multiply, this a is of denominator 1. So when you cross multiply, you have at is equal to v minus u. When you cross multiply, this times this, and then this times this. That's how it will be. Similar to what I've done. Okay. All right. So this is how to derive the first equation of motion. Very, very simple. So you consider a uniformly accelerated motion, its initial velocity u, and then final velocity v. Then you determine the acceleration, and v is equal to u plus at. Can't you derive this, class? Can't you?
Yes.
Yes.
Oh, you mean you can't derive? Oh?
We can say.
Okay, so let's look at how to derive the second and then the third equation of motion. When I call you to express your view, please just feel free. Getting it wrong is part of learning, okay? So don't be worried, maybe I'm not so clear. No, try. Try and then tell us what you think. When it's wrong, we'll all make it right. Now, the second equation, we must consider average speed. Average speed, which is the effective speed or velocity. Here we are representing average speed by v subscript a v. Other books also use v bar. So in kinematic or linear motion, when you see VAV or V bar, it stands for average speed. V with a bar on top. Okay. There are two different ways of determining average speed. And we've learned one of them. Total distance over total time taken. The other way out is that if you have a uniformly accelerated motion, V T graph, and the graph is a straight line, meaning the acceleration is uniform. The initial speed is here, u. The final speed or velocity can be traced to this point. So this is v. I can also determine the average speed by summing up the initial speed and the final speed and dividing by 2. So for a uniformly accelerated motion, yes, either total distance, and don't forget total distance would also be the area under the graph So this is the area under the graph over the total time taken from here to here. The time is this. Or initial velocity plus final velocity divided by 2. These are all ways of determining average velocity. Right? So the average velocity, which is equal to S over T, and it's also equal to U plus V all on 2. So we have two ways of finding average velocity now. Any question? All right. So, Frank,
Can you explain the other formula for the average speed again?
Frank, you see, mathematically, if you have A and B, and I ask you to calculate for the average, how would you do that? How would you calculate for the average?
A plus B on 2.
A plus B on 2. So what I'm saying is that if you have a uniformly accelerated motion, V T, uniformly accelerated, and the initial velocity is U, the final velocity is also V. Then the average speed can also be the initial velocity plus the final velocity divided by 2. So what this will give you, taking total distance over total time would give you the same thing. That's why I'm equating S over T to this. Frank, are you fine? Quantiwa, are you there?
Yes.
Yes, please.
So I'll start calling if you if you want to be quiet. Okay. So since S over T is equal to U plus V over 2, when you make S the subject, you have U plus V over 2 times T. Okay. To derive equation 1 on and 3, 2 and 3, this is all that you need. You must just understand the concept of average velocity. Average velocity being this or this. That's all. Now, let's substitute equation 1 into this. Equation 1 is V is equal to U plus AT. It means wherever you see V in this equation, in the average velocity equation, substitute V. So we have S is equal to U plus, this is V. Wherever I see V, I'm going to substitute U plus AT. So U plus AT all divided by 2 times time. So don't forget this is for V. This is just for V. Then I simplify what I have there. S equals 2U, U plus U, 2U plus AT all divided by 2 times T. Now, if I have that, then within the bracket, I can divide all the numerators by the denominator 2. So S is equal to, I pick 2U and divide by 2, and pick AT and divide by 2. All times t. This 2 cancels this, and s equals u plus at over 2 times the t outside the bracket. The final thing is that multiply through by the t, which is outside the bracket, and I have t times u, I have ut plus at over 2 times t, I have a t squared over 2. Ladies and gentlemen, this is the second equation of motion. Ut plus half at squared. This is the second equation of motion. Okay, so we derive this by just substituting the first equation of motion. We substituted the first equation of motion into the average velocity equation. Then played around and blah, blah, blah. That's all. Any question? Any question? Disciples of physics? Okay. All right. If there is no question, let's continue. The third equation of motion. Let me go to the messages. Read your messages. Okay. Oh, how did it become half? You see? Okay. We had a t squared over 2. Okay. This a t squared over 2 is the same as 1 a t squared. The numerator is the same when we multiply 1. Any number times 1 is the number. So because we just wanted to express this as half, the reason for which we brought the 1 here. Okay, so this becomes 1 over 2 times at squared. Janelle, is that okay? So that answers your question. Equation 3. I said your understanding of average velocity is all that you need for equation 2 and 3. When you manage to understand average velocity, yes, average velocity can be s total distance over total time, which is also equal to initial velocity plus final velocity, all divided by 2. Okay, so this is the central nervous system for equation 2 and 3. Then we multiply through by time, had u plus v over 2 times t. From the same equation 1, help me make, yes, equation 1 is v is equal to u plus at. Help me make t the subject. Janelle, do that for me. Help me make t the subject from equation 1. Benjamin, Is it the first equation, the first two equations?
Yes, sir.
If you want to copy, please tell me, because sometimes I may not read and then, okay. So, say I'm not done. I will give you the chance to finish writing.
Thank you, sir.
Janelle, go ahead.
Please, A is equal to V over U plus A.
Come again.
P is equal to V over U plus A.
Did you say over U?
Yes, please, plus A.
You see, Janelle, look here. You are making T the subject, and T multiplies A. U is just adding to AT. So you first must think of eliminating U. Think of eliminating U before you think of T. So, Janelle, how would you eliminate U from the equation? First and foremost. How will you eliminate this U?
Yes, you bring it to the other side.
And because it's positive, it will be negative, isn't it?
Yes, please.
So it will have V minus U is equal to AT. Then how would you make T the subject? Janelle. Benjamin, you hear you.
Yes, sir.
Divide the A.
Okay. Come again.
Yes, you divide the A.
So you divide through by A. Divided by A, divided by A. Then, so this is how you must look at it when other terms are adding to a variable. Janelle, are you okay? So we have T is equal to V minus U all on A. Anna, are you there?
Yes, sir.
Okay, so V minus U all on A. Now substitute this into the average velocity formula. We have S equals U plus V all on 2 times T, which is now V minus U all on A. Class, simplify this for me. We have two products, this one and this one. Simplify it for me, the right-hand side. And I'll call any one of you for what you had. So please be involved in doing it. Frank, let them also try, okay? Ablina, are you through with the simplification? Okay, Gideon. Gideon is ready. Let's hear from Gideon.
The simplification, S is equal to V square minus U square all over 2A.
Thank you. Difference of 2 squared. So V squared minus U squared all on 2A. I want you to help me make V squared a subject. Help me make V squared a subject. Gideon, are you still ready?
Yes.
Go ahead.
Okay. So you cross multiply.
Give me the final value. Just the final expression.
Sir, please a minute, I'm coming.
Okay. Okay, Giovanni.
Sir, please, I'm done.
Okay. Gideon.
Sir, please, V square is equal to U square plus 2AS.
Ladies and gentlemen, this is the third equation of motion. So simple to derive. Isn't it? Frank. Giovanni, your hand is up. Is it a question?
Sir, this is a question.
All right, I'm listening.
Sir, please, why did we use the the formula we derived when we made time the subject in finding the third equation of motion?
You see, all that I said earlier is that the second and third equation of motion just hinges on uniform accelerated motion. Uniform accelerated motion. Sorry, average velocity. So once you have the understanding of the average velocity, which is S on T equals U plus V on 2, this is what helps you, or what will enable you find the third and then the second. So for the second equation of motion, using equation 1, V is equal to U plus AT, just substitute this in place of V. And using the third, deriving the third, make time the subject in the same first equation and then substitute. So with the second and the third equation, we just make use of equation 1 and then the average velocity equation, and we are good to go. And basically that is how to obtain the second and then the third. So the Y is to enable us find the third equation of motion and the second equation of third equation of motion, which helps us in solving problems under motion. Giovanni, so that's the reason. Okay. Any question? If you have any more questions. Okay, so do not forget that U, we said, is equal to initial velocity, V, initial velocity, V is the final velocity, then S is the distance or displacement, and then A is the acceleration, S, T is the time taken. So you must understand the letters as used in the equation. Okay. Now my question is that for average speed or for speed, we said speed is distance over time. Then we are also saying the same speed being calculated as using equation of motion V is equal to U plus AT, and V squared is equal to U squared plus 2AS. What is the difference between the speed calculation here and then these two speeds? when do we use this and when do we use this, class? That's the question. When do we use 1 and when do we use 2 to determine speed, V? Anybody to help? Gideon.
Sir, please, we use the one when we have only been given the distance and the time.
And we use the 2.
And we use the 2 when we have been given the acceleration and the distance.
So practically, how would you explain this practical motion situation?
Okay, the first one will be for the distance time, the distance against the time graph.
Okay. All right. Any more view before I come in? All right. You see, when a body moves, Benjamin, Oh, Benjamin, I'm listening. All right. When a body moves and the motion is such that the speed or the velocity of the body is constant, when velocity is constant, when speed or velocity is constant, what is the value of acceleration? Class, if the speed or velocity of a moving body is constant, what is the value of acceleration A? Yes.
0.
0. So look at something. If V A is 0, equation 1, look at how it will tend to. If A is 0, it means final speed is equal to initial speed. And when final speed is equal to initial speed, the body is moving with a constant or uniform speed. Constant or uniform speed when A is 0. Now for equation 2, when look at something, oh please. When acceleration is 0. Gerard, mute yourself. When acceleration is 0, this part also goes to 0. And we still have V squared equal U squared, meaning V will still be equal to U. So class, what it generally means is that equation 1 and 2 are used when the body accelerates. When the body accelerates, okay, when the body accelerates, that is when to use equation 1, 1, even 2 and 3. The equations of motion are used when a body accelerates, uniformly accelerated motion, where the speed V changes with time, either increasing or decreasing speed. Now, when the body does not accelerate and you are calculating for speed, then V must be equal to the total distance covered, because here the velocity of the body is the same from start to finish. So acceleration is 0. Okay, and look at the third equation of motion. When acceleration is 0, S is equal to ut plus half at squared. If a acceleration is 0, this part goes to 0. And we have s is equal to ut. When you make u the subject, we have u is equal to s over t. So when acceleration is 0, it comes back to the average velocity equation, s over t. So we use 1 when the body does not accelerate, or when acceleration is 0, and we use equations of motion 1, 2, 3 when the body accelerates. Please, is that understood?
Yes, please.
So take note of them. Okay, Lodina, I'll communicate to you, okay? I'll communicate to you off the page so I can see what to do to help. Lodina, are you there? All right, class, let's try a question. Let's try and then use the equations of motion to solve a question. A racing car increases. A racing car I can't write everything. Time. Increases its speed at uniform rate. Increases its speed at uniform rate from 30 meters per second to 40 meters per second in 5 seconds. In 5 seconds. So class, listen, we are told a racing car increases its speed from 30 meters per second to 40 meters per second in 5 seconds. How would you describe the car? I haven't come to the question, but class, if a racing car increases speed from 30 to 40, how would you describe the motion of the car? Yes, anybody?
The car is accelerating.
The car is accelerating. Why? Because the speed is changing within a given time. So the question is that find its acceleration. Find its acceleration. Find the racing car's acceleration. Simple question. Benjamin, are you?
Please, is it 30 or 20?
It increases from 30 to 40. It increases speed from 30 to 40 within 5 seconds. Benjamin. Benjamin, I'm listening. Oh. I have Frank. What's your answer?
2 meters per second squared.
2 meters per second squared. Yes. So acceleration from equation 1, v is equal to u plus at. Therefore, a will be equal to v minus u all on t, and initial velocity for our final velocity 40, initial velocity 30, divided by a time interval of 5. So we have 10 divided by 5, which is 2 meters per second squared. Second question. Please, I'm sure you are all getting it correct. Are we?
Yes.
Okay. A cat, C-A-R-T, not the domestic cat, but the shopping mall cat. A cat moving at 9 meters per second decreases. Sorry, it's not decreases. A cat moving at 9 meters per second decelerates uniformly at the rate of 0.16 meter per second squared. A cat moving at 9 meters per second decelerates uniformly at the rate of 0.16 meter per second to 6 meter per second. How much time is used or is taken? How much time is used / taken? A cat moving at 9 meters per second decelerates uniformly at the rate of 0.16 meter per second squared to 6 meter per second. How much time is used or taken? So class, go through it. Let's see what you can. Are we through?
Sir,
Hello? Are we through?
sir,
Yeah, Imelda.
the answer.
Yes. Imelda, your hand is up. Let me hear from Imelda.
Sir, please, I had 18.75 seconds.
18.
0.75 seconds.
Okay, that's Emelda's answer. Let's hear from the rest of you. Yes. Benjamin.
Sir, 187.5 seconds. Sir,
18. Okay, the same answer as
one.
Emelda had. Okay. Okay. All right. So let's see. I've seen the feedbacks from some of you. Some of you are also getting negative. It should be a positive because deceleration is negative. So it would make it positive. So using V is equal to U plus AT, we are told that a cat moving at 9 meters per second decelerate uniformly at a rate this. So this is the deceleration. And don't forget, deceleration is negative acceleration. So here, because it's a deceleration, A will be negative. What is the final velocity? The final velocity is 6. So 6 is equal to 9 plus negative minus 0.16 t. Okay, so we have 6 minus 9, which is negative 3, is equal to negative 0.16 t. Therefore, t equals minus 3 divided by minus 0.16. And that should give us approximately 19 seconds, or your 18 point. That. Please, is that clear?
Yes, sir.
All right. A final question. Gideon. Gideon, I'm listening. Okay, it's a mistake. A jet starts from rest. A jet starts from rest and accelerates uniformly at 3 meters per second squared. A jet starts from rest and accelerates uniformly at 3 meters per second squared. So the acceleration of the jet 3 meters per second squared. What is its final velocity? What is its final velocity and the distance it has traveled from? What is its final velocity and the distance it has traveled from starting point after 20 seconds? What is its final velocity and the distance it has traveled from starting point after 20 seconds? Benjamin, your hand is up.
Sir, I didn't hear the question well.
So a jet starts from rest and accelerates uniformly at 3 meters per second squared. And accelerates uniformly at 3 meters per second squared. What is its final velocity and the distance it has traveled from the starting point after 20 seconds. What is its final velocity? That is I, and I. The distance as it has traveled from the starting point after 20 seconds. So after 20 seconds. Benjamin, your hand is still up. What is your secret? Okay, Oscar, I've seen your answer. Gerard. Gideon, I guess you are true. Gideon, I'm listening. What's your answer?
Sorry, the final velocity is 60 meters per second. And the distance is 600 meters.
That's what Gideon said. We'll go through to confirm whilst we wait for the rest to quickly. Who else has managed to finish? Who else has managed to finish? Amelda, Janelle, Rodina, Anita, Anna. Frank, what's your answer?
Final velocity is 60 and the distance traveled is 120 meters.
120 meters. Can I get a response for from our ladies? Any one of them? When you are speak, you are there. Oh, Benjamin, question. I just start from rest. And accelerate uniformly at 3 meters per second squared. What is its final velocity? It starts from rest. What is its final velocity? Okay, and the distance it has traveled from starting point after 20 seconds. So it starts from rest, meaning that the initial velocity is 0. When a body starts from rest, it simply means that the initial velocity is 0. When it comes to rest, the final velocity is 0. And we are told it accelerates uniformly at a rate of 3 meters per second squared. What is its final velocity and the distance? Okay, it has traveled from the starting point after a time of 20 seconds. So we are looking for the final velocity. Okay, so using V is equal to U plus AT, that's what help us find the final velocity, because U is 0, A is 3, and the time is 20. So we have 60 meters per second. Okay, 60 meters per second. If we can use equation 2 and 3 for this because they involve distance covered and we have no idea now. So once we found final velocity, then we can use either equation 2 or 3 to find the distance traveled. So once our final velocity is 60, 60 squared equals initial velocity 0, 2 times acceleration is 3 times s. Okay, so s is equal to 60 squared is 3,600 divided by 6. 2 times 3. It means that this goes into this 6, and our answer is 600 meters. If we are to use equation 3, equation 2, S is equal to UT plus half AT squared. The value must be the same. U is 0, so this part goes to 0. Half times the acceleration. Acceleration is 3 times the time is 20, so 20 squared. 20 squared is 400. So 2 goes into 400. 200. 3 times 200 is still 600 meters. Please, any question? Any question? No question. So this is where we draw the curtains on today's meeting. Please, I'll upload the video. Now a request from you, when you go to my page, YouTube page, please subscribe and share for me. Subscribe and share. Okay. I need more subscriptions to develop the channel. I'll be looking forward to that. So we meet once again on Thursday. May the good Lord be with you. Please, if you have problems, WhatsApp me. I'll respond to it for you. Okay. Until then, yes, Benjamin, to get more money. All right. Until the next Thursday, we'll do. Take care and solve more examples. In fact, I'll send you work sets. Okay, to deepen your understanding. Bye-bye to all of you.
Bye.
All right. Bye-bye.
Bye-bye.
Bye-bye, Marilyn.
Bye-bye.
Bye-bye.
Bye.
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 All right. Okay.
Bye bye.
Bye-bye, Gideon.
Bye.
Let me end the lesson before I get
Bye.
tired of the response. Bye-bye.